Hi, and welcome to this video. Today, we'll be going over the Formula SAE team here at Michigan Tech. We're excited to show you guys what our team has been doing this year to prepare for our competition coming up in May. Starting with just a quick overview about what Formula SAE is and how a competition is laid out for those who are not familiarized with it. Then moving on to what our team looks like here at Michigan Tech and what our team goals are for a competition. Then ending it with some of the projects that our team has been working on and that we're excited to show you guys all about it. Starting with what Formula SAE is. It's a competition that happens all over the world where students design, build, and validate their car. Every year within the rules, we have to start from the ground up, meaning that we have to make a whole new car, starting with the chassis and suspension in the aero package. We're lucky enough to have a national competition here in Michigan every May, where 120 teams show up from all around the world to see who is the best team. Our competition is split to two halves. First, starting with the static events, where we face industry experts defending our engineering design around a car, justifying the cost, and then also having a business case where we justify it to judges. Then we hit the track with dynamic events by starting with acceleration, then going on to skid pad and autocross, then ending it with an endurance event, where at the end they measure how much fuel we burn to get how much our efficiency. Today, our team is around over 50 members with diverse ranges of perspectives, having over 8 majors represented in our team. Splitting into 5 divisions and 7 sub-teams, our team is split up. This year, our team goal overview is finishing in the top 10. It's a milestone that we have not hit since the 1990s. We have a clear road path to get there. First, we are aiming to go into the design final this year, meaning that we are the top 10 teams in that event. And then second is having to finish first in acceleration event. These are our team goals, and every project you're about to hear is helping us to achieve these goals on this page.
Hi, my name is Evan Bogarzelski. I'll be presenting on the fuel selection capstone for Formula SAE. For the competition that we are going to attend in May, there are 3 possible options for fuel choices. Those would be 93, GT260, and E85R. The first 2 options are gasoline-based, while the last is ethanol-based. Currently, we run GT260 as it has an higher octane rating than 93. Another possible option would be E85, which has a very similar octane rating to GT260, but there are special rules regarding airflow when using E85. The intent of this capstone is to discover if those changes in airflow have a major effect on overall power, given that the higher latent heat of vaporization of ethanol would allow us to increase compression ratio or advanced timing to hopefully make more power overall. Our findings have discovered that in low RPM ranges, there is a slight power advantage to E85R, but for peak power, GT260 is the way to go. So that is our recommendation moving forward for the 2026 Formula SAE competition.
Hi, hello everyone. My name is Caleb Olson. I'm the Composites Division Director for Formula SAE. I'll be going over some key highlights and advancements we've been making this year as far as the aerodynamics team is concerned. So one of the main things that we've been able to do starting last summer is utilize Ford's wind tunnel to validate our real world data against our CFD correlations and simulations. So we tested last year's with the F25 package, and then again this spring in the F26 package. So directly, the magnitudes of our CL was 15% higher this year over last year's car with no added drag. So that's huge numbers for us, and that validates our CFD deltas from this year's car or last year's car, which is a large performance gain for 1 year change. And we expect to see with rolling ground conditions about a 25 to 30% increase in magnitude of CL, which is a large percentage. And also correlating last year's wind tunnel test to the car in CFD, we achieved a 99% CL correlation to CFD with both those CL and CD component deltas when we're analyzing individual components of the car, matching the increase and decrease in deltas of CL and CD in wind tunnel testing. So another great thing that we can do this year to maximize the performance of our package and maximize the points that we gain in our competition. So you see that figure showing the CO of our full package in the wind tunnel CFD, as well as with the conditions of just having the front and rear wing on, and how it matches very, very closely with our CFD and wind tunnel. And then there's a video showing some smoke wand testing with lasers to visualize how the flow is moving around the car. That is from F25. It's not from this year's car. So we were able to analyze this and see that there is a lot of flow that is avoiding the radiator, and we weren't utilizing the cooling as much as we could last year. So that was a big reason for some updates that we made to our package. Another huge advancements we've been making is on the CFD side of the team. So we've been able to create realistic and correlated values and simulations for radiators, which is huge, so that we can design properly around radiators and cooling. And as you can see, we increased our mass flow in one radiator by 75% over last year's car, which means that we were able to run one radiator this year instead of two, while maintaining the amount of cooling that we required, which saves a lot of weight and boosts the performance of the car more. And then the other part of it, as this video shows in the bottom right, is a coring simulation. It's fully parametric. All you have to input is radius, and if you're turning left or right, and the simulation will do the rest. This is a very important tool to maximize the performance in a corner and show how COP migration and all of our force values are changing in a corner. That is really where aerodynamics is important. And as this second bullet shows, that the coring simulation showed a 0.36% loss of CL per degree of vehicle roll, which really shows that our package performs well where it should be. And that figure in the bottom left just shows the difference of last year's mass flow rate in the radiator to this year's flow rate at 14 meters per second, which is a pretty common occurrence of coring simulation.
Good day, my name is Isaac Degner, member of Formula SAE Enterprise at Michigan Technological University. We've been afforded the opportunity to take our car that we use for competition and run it through wind tunnel testing at Ford's testing location downstate Michigan. So the entire scope of this project is to best optimize our time while we are utilizing this wind tunnel. So we decided to run approximately a 10% scale model this year, running our current F25 configuration of our car, and we ended up subjecting it to CFD and star CCM, as you can see from one of the configuration plots in the top right, and then trying to correlate it with wind tunnel experimental results that we were able to extract in the sub-basement of the meme with assistance from Dr. Kevin Howard. As you can see on the left side, we ended up running simulations for no aero elements, front wing only, rear wing only, front and rear wing, and we were only able to collect experimental data on no aero elements as well as front wing only. Looking forward into the project, we are looking at narrowing down the scope to testing individual wing elements that we can then print them off at a higher resolution and make better use of our boundary conditions to the wind tunnel that we have here. So when it comes to adapting them to the car, we know that we are making the best and most optimized choices for our machine and experimental data collection time that we are afforded. Again, special thanks to Dr. Kevin Howard for being able to help facilitate this and all the progress that we've been able to put together this year.
Hello, my name is Aaron Nicholson, and I'm highlighting the damper dynamometer project that the Formula SAE team has been working on. The primary contributors for this project are Peter Pollack, Bremen Samuel, Bo Iyer, and myself. The overview of this project is to construct a damper dynamometer that will help us generate these two plots, a force versus displacement and a force versus velocity. The force versus displacement is to help us validate an in-house rebuild on our dampers, and the force versus velocity is to help us set a baseline tune for our dampers. Here's the dyno use flow diagram. First, a scolia will start, a damper rebuild will occur. A validation of rebuild will then occur. After all dampers pass, a baseline tune and/or sweeps may be run on the dampers before vehicle testing. After that, vehicle testing will occur for fine-tuning of the dampers, and then competition will occur. As for our design, we decided to use a mill and a Scotch yoke to both power and actuate our dyno. We use the Scotch yoke with an interchangeable wear plate that can be easily manufactured and replaced if need be in the future. As for our data acquisition, we are recording both displacement as well as force in both the tension and compression going through the damper. This is then recorded with an Arduino and then sent to a laptop to be logged. For this final assembly use, first, the user aligns the input shaft with the chuck of the mill, then clamps the dyno housing to the mill bed, then hooks up all electronics and is ready for use. In this video, it highlights the use as well as the live DAC UI that we have for our system. The live DAC UI can be utilized in almost virtually any browser and features a force versus displacement plot as well as live output data from both the load cell and the linear potentiometer during the use. As you can see right here, you are able to select your baud rate and recording rate, as well as you are able to select a manual or automatic mode for how long you want to log data. It also features your sample rate and any other information that you might want.
And with that, thank you for watching our video. We're excited to meet you guys at the Design Expo coming up.